Monge's original right angle planes, they defined 4 separate spaces, or say quadrant. We will see later that what is the quadrant and what are its names. So in this view we can see there are 2 planes perpendicular to each other, and this is called the first quadrant. So this is the imaginary plane we can observe perpendicular to each other. So the first quadrant is called first quadrant, and the top left quadrant is said fourth quadrant. So if we move the first quadrant, second quadrant, third quadrant and fourth quadrant, as we can see in the drawing, if we draw the projection of this cone, so this will be our horizontal plane and this will be our vertical plane. So if we see from this side, the projection will be visible on the vertical plane. So in first quadrant, the front view will be above the XY line. Let us imagine that this line is XY line. So in first angle it will be above XY line, and this plane will go down, it will rotate in this way, so our top view will be below the XY line. So first quadrant, and after that second quadrant, and this way it will exchange the position. So in third quadrant the front view will be below this XY line, and let us say below the horizontal plane, and this way the top view of the third quadrant will go above the XY line. So it will be totally opposite to the first quadrant. So this is the main difference between first and third quadrant. And as we can see in fourth quadrant, this view and this view will overlap, same like in second quadrant. We are not using second quadrant and fourth quadrant in practical. So in engineering, hence the first quadrant and third quadrants are used, and so it is called first angle projection. So consider the first quadrant. The resultant drawing of the cone would be obtained by flattening the 2 perpendicular projection planes, as we have seen before. So the first quadrant will be, if we looking from the left, the side view will be drawn into the right side. So this is the difference. So in first quadrant, first angle position, for this example we can say that the right hand side image is the plan or top elevation, and the imaging is in the left side. So basic difference will be in object. If it is drawn in the first angle projection, we are looking from the left side, and it is drawing, it will be in the right side. So left hand side view will be drawn into the right side of the front view. So the object is first for the first angle projection. So viewing, if we are viewing from the left, the drawn image on the right is your right view of the drawn project, and if you are viewing from the right, then drawn imaging is left, is your view is drawn on the right. So to conclusion, here is the example of first angle projection. So here is a fitting of piping is drawn in first angle projection. So let us say this is the front view, so the top view and the rear view, and this is the right hand side view. If you are looking from the right side, it is drawn to the left of the front view, and this side is left hand side view, so it is drawing on the right of the front view. So this is the basic difference, and on the top corner we can see the symbol for the first angle is visible. So if any drawing is drawn on the first angle projection, we have to mention by drawing this symbol. And the difference between the third angle projection, as we have seen, if we are drawing from the left, we have to draw the same view on the left hand side, and if we are looking from the right hand side view, we are drawing that view on the right hand side. So our front view will be below the XY line. So if we consider third angle, the resultant drawing of the cone would be obtained by flattening the two perpendicular projection planes as shown in the figure. So here, if we are viewing from the left, the drawn image on your left is your view of the drawing project on your right, and if we are viewing from the right, the drawn imaging on the right is your view of the drawn object on the left. So this is the basic difference between first angle and third angle. Let us see the example of the same drawing which is drawn in the third angle projection. As we have seen, the third angle projection symbol is changed here. So this is the symbol for the third angle projection. Here the front view is drawn below XY line, and if it is its left hand side view, it will be on the left of the front view, and if it is on the right hand side view, it will be on the right hand side of front view. So in orthographic projection symbol, as we have seen, it is drawn first the cone and then its side view. So in the both of the projection system, they are approved internationally and they have equal status. The system is must clearly indicated on every drawing. As we have seen before, the symbol must be shown so that the interpreter or the designer can understand in what angle the drawing has been drawn. So the symbol are as below. The first angle is drawn first by drawing the cone and then their projection, so the side view. So in first angle the projection is more common. The first angle is commonly used in Europe, while the third angle is popular in US and UK. Hence we are also using the third angle projection in our drawing, and hence the third angle projection symbol can be visible by drawing the first side view and then by showing the cone, so the front view and then side view. We have some recommended size. So it is drawn at the 30-degree angle, so the cone inclination is 30 degree. The diameter is drawn and the horizontal length is also specified, and the distance between the center of the cone and the side of the another view is 1.25 of that length. So in the figure, projection system symbols and recommended portion has been shown. So these are the specified dimensions. So if you see pictorial view, so the orthographical projection is used to show the accurate way of providing the information. So the basically in manufacturing and detailed design, this represented, we can see the pictorial view is to be shown in three ways. The first one is perspective, second one is isometric, and oblique pictorial projection. One by one we will see and discuss each method. So in perspective method, it is looks more or less like freehand sketching. The parallel lines appear to converge and meet at what it is referred to as the vanishing point. So it is drawn with the point of one reference. And in isometric, the reading lines drawing at 30-degree angle. For example, this object is drawn by 30-degree line, so we need to produce first the line which are 30-degree inclined and from any solid geometry with the reference to that line. So that is the basic difference between perspective drawing and isometric drawing. In isometric, all lines will be in 30-degree. So in pictorial view, as we can see, in our orthographic or say oblique, the front face sketch is always true shape. So our front view will be of true dimension, starting with two axes. So we are using x axis and y axis, one horizontal and one vertical. The third axis is usually drawn in 45-degree. So it will be in 45-degree angle. So two axes perpendicular to each other and third axis is 45-degree. And the length can be reduced by 50% of true length. So it's sometimes called cabinet projection. So to create orthographic projection on the drawing, we are using front view, left view, side view, and the top we can say plan. So we are using these four sides to draw the projections. And if we are drawing in first angle projection of the same object, this will be front view, this will be the left view, but as we are drawing in first angle, it will be on the right side, and right hand side view will be on the left side. And by extending this projection, we have to draw this line as hidden line. The hidden line means we have one object here, and from front view we are drawing a 45-degree line, and by extending those projection we can obtain top view. And then in the last we have to show the height, thickness and related dimension in the respective views, and hence we can complete the first angle projection drawing. So we have seen the first angle. So as we have seen the first angle and third angle, the difference, let us revise that what is the basic of engineering drawing and what is made of. So first is engineering drawing is a graphical language, and the word language are inadequate to describe the size, shape and features completely as well as concisely. Hence, engineering drawing in a typical technical drawing is used fully and clearly to define required engineered items with the standard convention for the layout, nomenclature and interpretation, appearance, size, etc. So in graphic language, let us say engineering application is used to represent surface, edge and contours. So in our projections, in our engineering drawings, we have basically surface, edges and contours. So surface we can refer planes, edges means lines and contours means radiuses. So this drawing is, the language is known as drawing or drafting, and as we have seen before, it can be drawn with the free hand like engineering curves and by using some instrument, and now we can also draw with the help of computer softwares. So as we know, the engineering drawing is a type of technical drawing which is fully and clearly defined requirement engineered items usually created in accordance with the standards, convention and layout that we have seen before. So the purpose of the engineering drawing, the purpose of the orthographic drawings will be, the first is, an engineering drawing is not an illustration. It does not specify or illustrate the object, but rather it is a specification of the size and shape of a part assembly. So we need to define clearly what is the size, what is the depth, or what is the width, and then important information on the drawing, and what are the tolerance or say dimensions, all the features of that object on the drawing. So as we can see, the step block example, or say a geometric composition with the all assembly with cylinder hole and perpendicular cylinder can be drawn orthographically this way, and we have to show the dimension. So elements of engineering drawing, we have seen that if a component, if we are using a language, graphic language, we can describe the object into this manner with the help of dimensions and orthographic projections. And we are using the word language, means we are using alphabets to show the radius, to fillet or say chamfer, and numbers to describe the object. So in graphic language, the line types, projection method that we have seen, and geometric construction that we learn, and in word language we are using lettering to combine this with the completion of engineering drawing. So here is the projection method. We have seen perspective and parallel, so we are using parallel and orthographic from that projection method to show the multi-view or axonometric view. And as we have seen, the two types of line, that is parallel projection. So this is our line of sight, and hence we are not using perspective projection. So orthographic, we are drawing the projection from the each and individual every points,